All right. Hi, Daryl. Welcome to today's interview. Here is the question I've pasted in the code share.
Mm,
So you're given a circular integer array nums where the next element of nums is, uh, or the next element of nums maximum length minus one is num0.
uh-huh.
And what you want to do is return the next greater number for every element in nums. The next greater element of a number x is the first greater number to its traversing order next in the array, which
Mm,
means you could search circularly to find its next greater number. However, if it doesn't exist, return -1 for this number.
okay.
So basically, you're given a array nums, and you're supposed to return an array of the same size. So
Mm,
if you look at the examples here, if you're given
mm,
1, 2, and 1,
yeah.
your output should be 2, -1, and 2.
Okay.
And yeah.
And the reason why it should be 2, -1, and 2. So the first one's next greater number is 2. So it's only
Mhm.
1 away, right?
Mhm.
And the number 2 can find the next greater one, which is -1. And the second one's next greater number needs to search circularly. So what it can do, okay, it'll also be two ways. So it'll start from here, it'll jump to this, do this, hit 1, and it'll jump for this one and become 2. Okay, that makes sense.
Yeah.
Okay, and okay, just to make sure it's clarified in my head, I'll take a look at this one as well. We have one over here, and it's two away. The output should be two. Why is the output two when it's only one away?
Um, Sorry for example two.
Yeah. Oh, I see, I see. Actually, so it's just returning the next greater number. Okay, okay,
Exactly. Yeah.
okay,
You
that
don't
makes
need to
sense.
do how far it is. Just the number.
Okay, okay, right. Hmm. So just thinking of these examples over here, why my initial thought is to have a, let's say, like a pointer, right? So for every single element in the array nums over here, what we could do is we could have a pointer. Let's say for this one over here, we could have a pointer at the very start, and for every single element in the pointer, what we can do is we can instantiate another pointer and basically move it forward until we find a like a number that's greater than it, right? So we'll hit like two for this example, then we move on, we find two, we look around, and there won't be anything, right? So then we'll just return -1, and then I'll hit number one, and then it'll like rotate circularly around and hit two. So the
Mhm.
first initial problems I'm beginning to notice here is that for two, if we were to take into account the fact that the array is circular, then this would end up recursively looping around forever, right? So it would be
Mhm.
going back and forth. And I guess a way, kind of fix to do that would just be to have a max variable. And basically, if you've gone through the loop at least once and basically we haven't found anything, or if like the value is the maximum, right? If the value is the maximum, then we know for sure that there isn't going to be one that's greater, and then for that one we'll turn -1, and then for everything else we'll just loop through it circularly, right? So
Mhm.
we'll keep that in mind for that one, and then for basically this one, the circular one, if we start off here and we notice that at the very end, right, the second pointer over here exceeds the length of the original array, then we know that we're going to have to loop through to the very beginning and search for this again effectively. So the time complexity of this solution would be O of basically n squared, because at the max you'll be cycling through the like for every single element, you could cycle through the array. Like let's say like you can cycle it through at a maximum of twice, because you'd have to go through the cycle and circle back once in order to fully determine whether or not you've found the number, or like found
Mhm.
like the next greater number, right? So
Yeah, that makes sense.
while an n squared solution is good, I'm gonna go ahead and try to think of a more optimized solution by, let's see, hmm. Okay, so an idea that I have right now would be to utilize something called a sliding window. And basically, what we could do is we could have, like, let's say we have this sliding window over here, left and right. So, what the right pointer could do is for every single element in the array, you could traverse through, right? So, we move this forward once, we move this forward once. the next time that you found something that's let's say like greater, for example, right? We find something that's greater than the current element at the left sequence, right? So, well, actually, yeah. So, okay, yeah, just like this do. So we have two pointers, left and right, and for the right one, we keep just moving it forward until we found something greater than the left. So, let's say like if r is greater than the left, then what we're gonna do is we know that this is the next greatest number that we've encountered after the left one, right? Then we can then the what we know is that we'll have like an output array, right? So we'll have output over this, and then basically output at the index of the left pointer, right? So output at the index of the left pointer is going to be equal to the value of the right pointer. So we'll do that is equal to nums of the right pointer over here. So we know that, right? So so we know that. So as we move through and iterate through for everything else, let's say we know this is the greatest. So what we can then do is since we know this is the greatest, we can continue to traverse this forward, right? I'm just gonna play around with this a bit and see if there's any ways we can get the other ones.
Sounds
So
good.
so we have two over here, right? So the right pointer is a 2. We just know the output for the left one is that one. So what we can then do is move the left pointer forward by 1, right? We keep the right pointer at the same area. And now with this one, we want to check to see whether or not it's basically greater. Well, it's obviously not greater because it's the same number. So then we move this forward. And then for this right pointer over here, we basically we know it's not greater. So then we do a cycle back again, and we hit the end of the array. Now, at this point, we can utilize the maximum, right? The maxi over here, and basically for every single check, so we'll check for every iteration of r, we can check and basically keep a maximum accumulator which keeps track of what the max is. And at the very end, we can then do a check to see if basically keep max accumulator, and then if we've reached like the right one has reached the very ends, if the left is equal to the maximum, right? Maximum, then we know for sure that that one's going to be the one that's -1, and then we can have that's output set to -1, right? So, and we know that this works because if r reaches the very end over here and it reaches nothing left, then we know that it's already seen the maximum value in the array, right? So once we see that that's empty in the array, the next the left pointer as it comes along, we're going to know for sure that one's going to be the maximum, and we're going to know for sure that's going to be -1. So yeah, that's what the case will be for -2 for 2 over here, right? So we hit the right pointer. Right pointer hits the end, realize, oh, that's the maximum, right? So then we move this left pointer forward, and then now we know what the left point, like we hit the left pointer over here, right? Now we take a look and see what where the right pointer is. It's at the very end over here. So at this point, we know that since it's reached the very end, it's most likely going to be the maximum number, right? Over here, that's going to be the value that it should be for the output. So the final result of this algorithm for this one will be 2, right? Because the left pointer will be able to deduce that the right pointer is at the maximum so far, and then we'll have a -1, and then we'll have 2. So that's my initial rendition of the algorithm. I'll go ahead and run through it with example number 2, since it's larger, just to see if I can detect any more flaws with it.
Sounds good.
Okay. So with the second one over here, like we said, we have the left pointer and the right pointer. We start off by traversing the right pointer forward. We hit 2. Okay, so the max equals 2 so far, right? And we check to see, is it greater? Oh, it is. So we know what the output of that one's going to be. So the output is going to be, for this one, it's going to be 2, right? So now we move forward. We check to see whether or not this is greater. Well, like left is greater than the right. Well, you can see from here that it's the same, so it doesn't work. So then we move the right pointer forward. Then we check again. We see, oh, is this greater? Well, it is greater. So then we know for sure that this one's going to be 3, right? So we switch this to 3, we move this forward again. Now we move this forward again here, this becomes 4, right? Is 3 greater than 4? Yes, it is. So then we know we hit that to 4. We move this forward, and then we check again. Well, no, it's the same, so we have to iterate the right pointer forward. We check for 3, and we see, oh, is it greater? Well, no, it's not. So then we move forward. Oh, it's at the end. So if it's at the end, then we know for sure that we have to keep iterating that left pointer forward. Basically, okay, I see. There's an issue here. So if we kept iterating forward, once it hits the end, if we just keep iterating the left pointer forward and assuming that every other max is just going to be the maximum, right? Which is at this point is going to be R. We know that it's going to end up looking like this, but that's not what we actually want. Well, it's going to be looking like this. Oh, actually, it is what we're going to want. Okay, right. You know, never mind. I was just thinking of it the wrong way. Yeah, and edge case I was thinking of was that maybe it should be equal to 3, but I realized it has to explicitly be greater than that value. So in this case, my algorithm would end up working. So are there any issues or clarifications that you would like me to make, or can I begin coding this up now?
Yeah, what is the time complexity of this?
So the time complexity of this one would be O of n, because at the maximum, you have the left pointer and the right pointer, and they'd be iterating through until both of them reach the very end. So in no situation would you have to like iterate at max to everything for every single one.
Okay, what about an input array that looks like this? What about something like this? Would this still work?
Okay, so we have the left and right pointer. Let's say we have, oh, sorry, okay, there we go. Left and right pointer over here. We have the max over here. We set, basically what we do is we check to see the comparison. Is less the right greater than the left? No, so we move this. Is left greater than the right? Well, no, so nope, nope, and nope. So we hit the very end, and at this point, what we know is the maximum is 5 over here, right? Because that's the greatest that we've encountered so far. Now, since the right pointer is reached the very end, we know that all we have to do now is iterate that left pointer forward. So we move this left pointer forward here. Well, we know since this one is equal to the maximum, the output is going to be equal to -1, right? And we're going to move the left pointer forward again. We'll hit 4. Well, since we just set everything to the max, we'll hit it to 5. We'll hit this 5, 5, 5, etc., etc., etc. So it would work in the situation because the next greatest circular one would be 5. If I'm not mistaken.
Okay. Last array I want you to check is something like this. Actually, hold on one moment.
Okay.
Could you try running it through with something like this?
Okay. So we have the left pointer here and we have the right pointer here. We check to see whether or not this one, the right is greater.
Sorry, let me do it like this.
Okay.
That's better.
Okay. Wait, what did you change?
Just flip the 2 and the 1.
Okay, so it says 4, 3, 5, 2, 1, right? Okay. So we start off with the right pointer. We check to see whether or not it's greater than the left. Well, we also have to have the maximum accumulator. We check and we see, okay, well, they're both equal. So then we just move the right pointer forward. We check to see, basically max of 4 is 4. We then check to see whether or not 3 is greater than 4. Nope. So we move this and then we hit 5. So at 5 becomes the new maximum, right? And we know at this point that we're gonna set the output for this one to be equal to 5 over here, and then we'll move the left pointer forward here, right? And now we check to see 3. Well, obviously it's greater, so then we're gonna set 5 to be the maximum value over here, and then we move that value forward. Now we hit this. Oh, they're both equal, so we don't do anything. We move the right pointer forward, and we hit 2 again over here, which is less than, right? So it doesn't, nothing happens. We move the right pointer forward. We move this one. Oh, yeah, also move the right pointer forward. Oh, it's empty. So, okay. So this is where, okay, this is what you're talking about with the issue,
Mm-hmm.
where you have 2 over here, and my max would be 5 so far, when you'd actually want to hit 4. Hmm. Okay, so interesting. Okay. Okay, so instead of a like a only just a minimum accumulator over here, I realize what we have to do is we'd have to have a some sort of a stack which keeps track of what the next possible minimum can be, right?
Mm-hmm.
So maybe instead of like for like this case, let's say we start off at the very beginning over here, right? So we start off with the left and the right, and then we encounter the value 4 over here. What we can do is we can append to the stack the value 4, move it forward over here, then we append it to it the value 3, right? And then we basically we encounter it as usual, right? So we just generate it again, basically keep moving it forward. We hit 5. We hit 5, and then we see that it's greater. So then what we do is we set the value to be equal to 5, and then we move it forward. Move it forward over here. Okay, wait, let's see. So actually, an idea that I'm thinking of would be to, word in this context or in this situation, do you think um, do you think a monotonically decreasing stack would also suffice in this situation, or am I overcomplicating things?
No, I think you're on the right track.
Okay, so maybe instead of just a regular stack, what we could have is a monotonically decreasing stack. And by that, I mean basically what it can do is check to see whether or not it's greater than the previous elements inside like the stack so far. So let's
Mm-hmm.
say like we start off at the beginning, right? So we add 4, we add 3, and then we add 5, right? So
Mm-hmm.
basically we know for 4, 3, 3 is less than 4, so on and so forth. We hit 5. Wait a minute. In this specific case, since a monotonically decreasing stack always has to decrease, we know for sure that something is wrong when you append 5 to it. So what
Mm-hmm.
you can do is we know for sure that all the elements previous to it, right, are going to have 5 as its value. So what we can do is let's say like we pop these elements for now, right?
Mm-hmm.
So we pop this element, and then we actually add 5. And
Mm-hmm.
as we pop those elements, what we can do is we can add their values. So we can have 4, and then we can have this can be 5, this can be 5 on our output array, and then we're back to where we are. So now we have a pointer over here, right? Now we basically move this forward. We hit a 2. Okay, it's decreasing, it works. And then we hit basically a 1, it's decreasing again. Now, this is the area in which we'd have to have had the previous values over here. So, maybe instead of popping those elements into stack, let's see. Okay, so maybe instead of popping those elements in the stack, we can just have it still there, right? So 4, 3, 5, 1, 2, 1, right? And then, okay, so another idea I have is to have like another one, right? So maybe like a popped array over here. And
Mm-hmm.
from this popped array over here, what we can do is all the elements that we pop, we can put into there. So we pop 3. Hmm. Actually, so we pop 3, and then we pop 4, and then we check to see what the maximum of that one is. But that wouldn't really make sense. So maybe just like I said before, we actually just don't pop it, and basically we just check whenever we add something new, we check to see
You should
whether or
be.
not.
Sorry, I think it should be 4-3.
Oh yeah, sorry, 4, 3, and
No
5.
worries.
So okay, we check for those ones, and then from here, what like the next natural progression in logic would be to grab the number 4, right? Because that's at the beginning. So there's two ways in which I can go with this. I can either create an entirely new stack in order to store what those values would be, right? 4 and 3, and then basically reference that stack whenever I hit the end of the stack over here. Or what I could do is I could keep it in the existing monotonically decreasing stack and just loop it forward around to the beginning whenever I need to. So I'm assuming that we need to create an entirely new stack, right? Am I correct? Or like an entirely new data structure in order to store the ones we've already gone through, right?
Mm, I'm not sure if that would work,
Okay,
but
okay, I see. Hmm.
yeah, I'm not sure if that would work.
Okay, so let's try to think of some other ways that might be possible for this.
It could work. I'm just not sure 100% about that.
Okay,
But you
so
could give it a try.
I'll continue thinking of other solutions if it's not the one that
Sounds
you're
good.
thinking of.
Sounds good. Yeah.
So we're at 5, 2, and 1, right? So we've reached the end of the array, and the issue that we have is that we're not sure like how to get like how to circle around back to the beginning, right? So
hmm
would utilizing a sliding window, like I talked about previously, help with the solution? Or
What do you mean by sliding window? Like, what would you be sliding?
hmm, well, I would have a sliding window at the. Let me think. Hmm.
So, here's a question I want you to consider.
Mm-hmm.
For a circular integer array,
Mm-hmm.
what's the maximum times you would need to iterate through it?
You would have to cycle it through it twice at the maximum. Yeah.
Okay, so twice,
Mm-hmm.
right? Think about how you could incorporate that into your current solution.
Hmm. Well, going back to what I was saying before, maybe we can have a left pointer and a right pointer, and then basically, I guess like the right pointer, it could add to the monostack, et cetera, at the very end, and then once that reaches the end, we'll have the right pointer over here, right? And now we'll have the
Mhm.
left pointer at the very beginning here, and then from here, with the remaining elements in the stack, right? We can check to see, since we have the left pointer at the very beginning, we can iterate through and
Why is the left pointer at the very beginning?
hmm, well, since you said to loop through it twice, my idea was to have a pointer at the beginning and loop through it again, checking to see whether or not it's larger than the we'll start off with like 5 over here. We'll loop through it again and see what the remainder values is. But I guess it doesn't really make sense to do that. Yeah, you're right. Hmm.
Why do you need a left pointer at all?
That's a good point. You might not need it. Maybe. Hmm.
So if you want to loop through the array twice, what would you do here once you reach the end?
Once you reach the end, you would move that right pointer to the beginning and move to the start, right?
Okay.
Oh, okay. So you move that right pointer to the start, and then you would check to see, basically add that to the stack, mono stack again, right? You hit 4, right? You append
hmm
4. Well, obviously it's greater than. That makes sense. So obviously it's greater than. So then you know what to populate this one. You need to populate this one with 4. You need to populate 2 with 4, and you need to populate 5 with 4, right?
hmm
So you populate those values, and then once it reaches
Oh, you
the
don't populate 5 with 4.
oh shoot, my bad. Wait, what? Oh,
The
oh wait,
third
right. You don't
element.
pop the 5 with the 4. So at the very end, you're left with this 5, and then the 4 over here.
hmm
Now, basically, well, I guess you don't even need to put this in. You can just do the comparison outside of it. And
hmm
then at the very end, what you know, what you know is that well, we could have like the maximum accumulated like we were talking about before, which keeps track for that edge case, right? So what at this point, what we could do is compare with the maximum and see whether or not it actually reaches it, and then we return for that one like -1, right?
Okay.
Well, would that work?
Um, yeah, so could you say that again? Sorry.
So like the first iteration, like as we're like creating the monotonically decreasing stack, what we could also do is we could have like a maximum accumulator. Well, not accumulator, but basically a maximum variable which keeps track
Okay.
of what the max is, and then if any value is equal to that one, that's when we're going to actually have to do put -1 for that one, right?
Okay. Yeah. So are you gonna keep looping through R, or do you just stop once you hit the first, once you come back to 4?
Well, once you come back to 4, you would you would since it wiped out most of it anyway, there'd be nothing in a monotonically decreasing stack except 5. So,
Mm-hmm.
and then then you would check to see whether or not it's equal to the maximum. So then it'll like okay, I see. Hmm.
Because it's just for this case where it just so happens that after
Yeah.
4, there's
Okay.
nothing
So
greater, right?
I'll imagine like let's say like we move the right pointer forward, right? Theoretically,
Mm-hmm.
and then we hit 3 again, and we add 3 over here, right? And once we hit 3, well, like once we have the 3 check over here,
Mm-hmm.
what we can do is we can check to see whether or not it's greater than, it's not, and then it'll loop forward, it'll do 5, etc., all the way to the very end, right? So we need to have some sort of way to stop it, or okay,
Right.
um, hmm. Okay, so hmm. Okay, so a thought I'm having, so for the second loop through, after we've looped through it once, right? Then we don't want to be actually adding the values to the monotonically decreasing stack anymore, right? Because we don't want it to keep going on infinitely.
Okay.
So maybe instead of like uh basically yeah, maybe instead of like adding it to the stack still, we can just have the R pointer forward and we keep moving forward. Um, we keep moving forward up until it hits the end the second time. And once it hits the end the second time, that's when you'll basically return like you'll return null. Or like you'll just return like -1 or something, right?
Okay. Return -1. What do you mean return -1?
So like once you cycle through the first time and we do what we said from before, and then
Mm-hmm.
we keep iterating through, we cycle the second time, and once you hit the very end, the second cycle,
Mm-hmm.
and basically there's no other number which matches like which will help like pop out the last value, then we just return nothing, right?
But you're supposed to return an array of numbers, right?
Yeah. So okay. Um let me just quickly run through this again with the new monotonically decreasing stack example that we were talking about.
Mm-hmm.
Okay, so we have basically empty output array over here, right? Mm, okay, we have a just a singular pointer. Doesn't need to be right or anything. We hit 4. We append that. We append that. Uh, we append that to the stack. We then go to 3. We append that to the stack. We then hit 5, right? Uh, we hit 5, and then we know that for 4 and 3, we're gonna set that to 5, right? Because it's greater than the values. So
Mm-hmm.
we'll delete that. We'll add 5, and then we'll go to 2 over here. Go ahead and add 2, and then we go to 1. We hit 1 over here, and then we hit the end, and we start off at the very beginning again, right? Uh, Start off at the very beginning again. We hit 4, and this time we stop adding it. We hit 4, and for 4, well, it's greater than 2 and 1, so we pop that from those, and then we add 4 and 4, and then it's not greater than 5. And since monostack,
What do you mean? You um, you're adding 4 for the 5, right? But 4 isn't greater than 5.
oh no, okay, right. Oh yeah, sorry, I meant like, it's like 4, and then we have like a 0 here, right? Or what the heck? 0, 4, 4, because it's like not populated yet, right?
But how do you know if it's not populated?
Well, we'll be referencing it by their indexes. Oh, so we'll have to also like keep track of what index that they have, right?
Mm-hmm.
So instead of like this one, what we can also what the monotonic stack will end up looking like would be like, let's say like 4, 0, uh 3, and then 1, etc.,
Right.
right?
Yeah.
Mhm. So we'll have, and then, okay, so basically back to where we were before, we have like 5 at index 0, 1, 2, and then what we do is we have to, okay, so so then like we have 5 at index 2, and then from here we check to see what 4 is. Well, for this one, 4 is the value greater? Well, no, it's not, right? So then we move this forward again. No, it's not greater. Oh, it's the same one. So at this point, then we would have this as a -1, right? And then like in a situation where we'd have to keep looping to the very ends, we hit this one, and then we check to see what the basically like we just set it to the maximum, right? Is there something I'm missing here, or
How do you know? Like you're very much on the right track. You're just missing one small detail, which is how do you know when to set something to -1?
we know to set it. We know that we have to set it to -1 if we hit the maximum that we found from the last cycle, right?
Okay.
So if we hit the maximum from the last cycle, say 5. Oh, okay. Hmm. So maybe every single check, we can just see whether or not it hits the maximum, and then from there, we can also pop that from the from the monostack, right? So
Okay.
if we traverse to the very end and there's nothing left, then we can check to see whether or not it's equal to the maximum, and then from there we can set that as the value, right?
So basically, you're gonna traverse to the end, and if it's left on the stack, you're gonna set it to -1.
Yeah,
Okay. Sounds good. Yeah. Could you try
yeah.
implementing this?
Okay, and like there's no need for a maximum accumulator, right?
Accumulator. What do you mean by
Or like a
accumulator?
maximum variable. I don't think there's a need for it.
Well, how are you gonna know if it's the maximum?
You're right. You're right. Actually, there's no need. Yeah, we just like go to the very end, and if there's anything left, we set it to -1. Okay.
Oh, wait. So what about this though? You still have 2 and 1 after, right? So are you gonna set those to -1 as well?
Wait, why would we have 2 and 1 after? So we.
Because you said like you're gonna keep looping through till the end, right? And if you
Mhm.
keep going, you're gonna have 5, you're gonna have 2, right? And you're not gonna pop anything off the stack because it's still monotonically decreasing, right?
Mhm. Well,
So you're gonna have like at the end of your 2 loops, you're gonna have this left on your stack. Am I right?
well, my idea with what I was thinking is like for the second iteration through, then I just wouldn't be adding anything. I wouldn't be appending to the stack anymore.
Okay, so
So
not
th-
appending to the stack.
yeah, and then from there, I'd just be strictly checking to see whether or not it's greater.
Sounds good. Yeah, that sounds good.
Okay, okay,
Do you want to try implementing this?
okay. Yeah, sure, sounds good. Okay. Could you actually paste like the class in the def
Yeah, I
thing?
got, I got you.
How long is that? That's pretty long.
How, that was, I think you took up a bit of time with your, or just finish it up and then we can talk,
Okay,
because coding it up takes a while too.
okay. So we're gonna have a monostack. First things first over here, and then I'm gonna do basically iterate through for v I guess for index and value in nums. Wait, nums. We're gonna want to append to the monostack. So just to see, we'll do like uh index and then value over here.
Yeah,
So
sounds good.
monostack, what we're gonna do is we're gonna append the index and the value as a tuple. So we'll do indexed and value over here. So first of all, we're going to append that, right? And then like we said, as we append, we can see if monostack -1. Oh, if the monostack exists first. Monostack stack and monostack -1 is basically if it's less than the current one, which is the value, then we know that we're gonna want to pop it. So maybe while monostack and monostack -1, we're gonna do monostack dot pop, and then basically, yeah, we're gonna pop the value, and then we're gonna want to add from there we want to add it to our results array, or our result over here.
Mm-hmm.
So go ahead and do that. So we'll have the results array over here, return res, and then we'll have like maybe like latest equals monostack.pop, and then from here, or I guess like index latest value is equal to monostack.pop, and then we're gonna want to have the output be res at the latest index is going to be equal to the current value that we're at. So we'll have that equal to v, right?
Mm-hmm.
And I just realized we also have to populate this, so we can initialize it with the value, let's say like -1, and we'll multiply that by the length of nums.
Mm-hmm.
So basically, it'll just create like an array, like the nums, and then after we do that, basically we pop every single element from the stack, and then we'll reach the very end of the array, right? So
Mm-hmm.
after this, we know for sure that it could be a scenario where you have like the maximum at the very end, and then some other values which haven't detected the cycle. And like we said that we're going to do before, we're going to loop through it again for index value in enumerate.
Just before you do
Or
the second loop,
yeah,
this is never going to. First of all, you're missing a syntax indexing for the this part right here because you need two
oh right,
elements, right?
right, that makes sense. Monostack at the value. So we'll do monostack dot seconds, right?
Okay. One more thing. This will never um this won't ever run because
Oh, you're penning it to the stack, right? So then you're gonna have to basically move this to the very end. Is that what you're gonna say? Or
yeah.
okay. Yeah, we're gonna want to do that after we pop the elements in the stack. Okay, yeah. And then next thing we're gonna want to do is oh wait, before I go, is there anything else that I should clarify or like edit, or can I move on to the second loop now?
No, go ahead.
Okay, so this time we actually don't need the index. We just need the value, since we're just trying to compare for it. So for v in nums, what we can do is while monostack and monostack -1 dot seconds is less than the value. Oops, it's kind of strange. Okay, there we go. Then we're gonna want to do the same thing. So we'll pop the latest index and the latest value like this, and then from here we'll set the result of the latest index to be equal to the value, and then we reach the very end, right? And if there's anything else at the very end, what we can do. Oh wait, this might have to. Okay, let me think. Yeah, okay. Yeah, that makes sense. Okay, so at the very end after this, what we're gonna want to do is we're gonna want to basically check if all values left in the array. So for values in monostack, or let's say index and value in the mono stack over here, what we can do then after that is, or actually we can do like for value in monostack, right? For every single value in the monostack, we know for sure that's gonna be -1. So we're gonna do like let's say like the results at the index, which is the first one. So mono v dot first is going to be equal to -1, and then at the very end, that's going to be our final result, right? So let me just walk through this again to check for any errors. We create a monostack with index and value, and we initialize the results array. We iterate through basically having the while loop over here. We pop the element from the stack and we add that as to the results array. We append it to that, and then for the second iteration, we only need the value, so we don't actually add anything to the stack. We'll iterate through and check to see whether or not it's any less than the value. We'll pop it from the stack and we'll add it to the result if it is, and then at the very end, we'll set it to -1 if any value still exists. So is this a valid solution?
Yeah, let me just run it through.
Okay.
See if this works. You can try this yourself too. It's called nextGreaterElement2.
Okay, bet.
If you want to stop the timer, that'd be good.
Okay, okay, good. Stop the. You mean the stop the recording, right?
Yeah.
Alright.